Part 4. We are starting off with the prescriber ordered morphine, 100 milligrams in 100 mLs, and they gave us a rate of 0.005 grams per hour. How many mLs will the patient receive per hour? So first I'm going to change this to milligrams. The question is asking for milliliters. So this will just be an easier conversion. Remember, we're going from grams to milligrams. We're going in that direction. So that's the direction I'm moving my decimal. And I'm moving it 3 places. 1, 2, 3. So that puts it at 5 milligrams per hour. Then the other pertinent information is that we have 100 milligrams. Milligrams is in the denominator, and we have 100 milliliters. So how many mLs per hour will the patient receive? So the hundreds can reduce each other, cancel out. So I'm left with 5 mLs per hour. In example 14, I'm looking at the prescriber ordered 250 milliliters, 5% D5 and W. That's just a solution. We don't really care about that right now. We have 9 milligrams in the 250. This is our order. So I'm going to start with my .001 milligrams. And remember, when you see this setup, kilograms times minutes is in the denominator. So this is my order. Next, I usually put my weight. 80 kilograms over 1. Then I put my concentration, which is 250 milliliters over 9 milligrams. And then I look at my problem and see if I need any conversion factors. So we're calculating it in drops per minute. So now the patient weighs, the drop factor is 20 drops per ml. So I want my 20 drops in the numerator. Drops per ml. So this will make my milliliters cancel out. My milligrams will cancel out. My kilograms will cancel. And I'll be left with drops per minute. And that's what the question's asking. So when I get my calculator out and I take 0.001 times 80, what did I do? Times 250 times 20, I get 400 divided by 9. 44.4, which is 45 drops per minute. Okay, so now I see this in my problem, so I know that's what I'm going to start with. Milligrams, kilograms times minutes. Then I go with my patient's weight, which is 75 kilograms over 1. And then I do my strength, which is 60 milligrams. My milligrams goes in the denominator, so I can cancel. My 60 milligrams is in 250 milliliters. And they want it in drops per minute, so I'm given 20 drops per ml. 20 drops per ml. My milligrams cancel, my milliliters cancel, My kilograms cancel. I'm left with drops per minute, which is what I want. So my units are in drops per minute. And when I multiply my, let's see, I'm multiplying 0.006 times 75 times 250 times 20. And divide that by 60. 37.5, so I round that up to 38. 38 drops per minute. So next I have the same type of setup, so that's what I'm going to start with. I have 1.2 grams, but everything else is in milligrams, so I'm going to automatically change my grams to milligrams. So I'm going from grams to milligrams. So I'm moving my decimal to the right. So 1.2, 1, 1.2, 1, 2, 3. So that becomes 1200. So I have 1200 milligrams over m squared times day. The m squared is similar to my weight, so I'm going to put that next. 1.5 m squared over 1. My strength is 50 milligrams per ml. Now here, they're running it in 30 minutes every day. So one day is 30 minutes of infusion. If I would put 24 hours, that would be like it would be running over all 24 hours, and that's not the case here. And they want it in hours, and right now I have it in minutes. So I have to put 60 minutes. My minutes cancel, my days cancel, my m squareds cancel, my milligrams cancel, and I'm left with mLs per hour. So I'm taking my 1200 times 1.5 times 60, and I'm dividing that by 50 times 30, and I need to put that in parentheses, 72. So my answer is 72 mLs per hour. Okay, so here I'm starting with 3 micrograms per kilogram per minute. How many milligrams? So I'm going to change my micrograms to milligrams right away. So I'm going from micrograms to milligrams, so I'm moving my decimal that way, 1, 2, 3. So I would have 0.003 milligrams over kilograms times minutes, and then we have 176, so 176 divided by 2.2 gives me 80 kilograms. So now how many milligrams per minute? I have that. Kilograms cancel out. So now all I have to do is take my 0.003 times 80, and I get 0.24 milligrams per minute. how long will it take? So now I'm doing 50 milligrams. And I'm putting in my 24 milligrams per minute. The 24 milligrams would go in the denominator to cancel out the units. 24 milligrams per minute, and this is a decimal here. And that 0 should be in front so you don't miss the decimal point. And they want it, I'm going to change it to hours and minutes, so I'm going to do hours over 60 minutes. So now I do my 50 divided by parenthesis 0.24 times 60. And I get 3.47. So that's 3 hours and 0.47 of an hour. Now 0.47 of an hour doesn't tell me a whole lot. I want to know how many minutes that is. So to find that, I subtract out my 3. There's just my fractional equivalent, and I multiply it by the 60 minutes. And that tells me it's 28 minutes. 3 hours and 28 minutes. And then in example 17, we have 300 milligrams of an IV drug in a piggyback in 100 milliliters normal saline that we're putting over an hour, 60 minutes. How many mLs must be added? That's a key word right there. To the IV bag if the vial has 75 milligrams per ml. So we're actually finding the pump setting. So here, first we have to find out how much we're pulling out of the vial and then adding it to the IV bag. So we're going to take our 300 milligrams over 1. Let me see if I can get this. Times the strength. 1 ml has 75 milligrams. So when I multiply that out, I get 4 mLs. That's what I'm taking out of the vial, and I'm putting in the piggyback. So I'm adding 4 mLs to the 100 mLs. So I get a total of 104 mLs, and I'm infusing that in the 60 minutes, or the 1 hour. So my pump setting would be 104 milliliters per hour. And that wraps up part 4.